Okay, in this video I'm going to talk about LeChatelier's principle, and basically this is addressing the idea that we have a system that's already come to equilibrium. So the equilibrium we're going to use as our example here is nitrogen gas and hydrogen gas coming together to form ammonia, and ammonia splitting back up to form nitrogen and hydrogen gas. So the idea is we have some nitrogen, hydrogen, and we've allowed it to come to equilibrium, so it's settled out. The forward reaction and the reverse reaction are equal to each other. And then we're going to imagine we make a change to that system, and we're going to look at how that affects, or how the equilibrium will shift to respond to the change that we've made. The principle states that a dynamic equilibrium tends to respond so as to relieve the effect of any change in the conditions that affect the equilibrium. So basically, if you change something, the equilibrium will respond in a way that tries to change it back. Let's take, for example, and in this video, I'm just going to talk about what that means and give a couple examples. And then in subsequent videos, I'll explain why equilibriums in the different situations would tend to try to go back to their original state if you change them. So here, in our equilibrium, we're going to imagine that we add nitrogen gas. So we're going to increase this. So what that means then is that the equilibrium will shift to the right. So more ammonia will be produced. That will use up some of the nitrogen gas that was introduced, and as a result, will go back towards the concentration of nitrogen that existed there in the first place. So again, if you add nitrogen gas, the equilibrium will respond in a way that tries to eliminate the change you made. So it's going to try and remove some of the added nitrogen gas. We're not explaining why. We'll do another video on that, but here we're just talking about what the principle predicts. That means then, if we imagine we are chasing around the concentrations of nitrogen, hydrogen, and ammonia, respectively, and I'll use 3 different colors here so that we can keep them straight. Let's make the nitrogen gas, what did I do? Let's make the nitrogen gas black. We'll make the hydrogen gas blue, and we'll make the ammonia red. So the idea is I'm kicking along with these equilibriums, or I'm kicking along with these concentrations in equilibrium so they become stable. Then I'm going to dump a bunch of nitrogen gas in my system. So that's the introduction of that nitrogen gas. The system is then going to tend towards the right. It's going to use up some of the nitrogen gas. And when it does that, it's going to inadvertently use up some of the hydrogen gas. And it's going to produce more ammonia. So it tried to undo the change that you made to the system, and it shifted the whole equilibrium to new stable values. Another example is if I cooled the environment. So again, imagine I have nitrogen, hydrogen, and ammonia, and they're in this equilibrium situation. The amount of ammonia being produced and the amount of ammonia being used up has become equal. And then all of a sudden I make it colder. LeChatelier's principle says the equilibrium will respond in a way that tries to fight the change. So if I'm going to make it colder, the reaction is going to try and shift so that it's going to make it hotter again. If I look at this reaction, I can see that it's an exothermic reaction. Energy is being produced. If I go in the forward reaction, and if I go in the reverse reaction, be endothermic, or energy would be consumed. So if I cool the environment, this equilibrium will shift to the right in an attempt to produce energy that would heat the environment back up and try to avoid that change. What would that mean for all of the populations? So again, I'll make nitrogen black, make hydrogen blue, and ammonia red. So again, I'm starting at an equilibrium situation where all of my populations have become stable. The amount of product being used up is equal to the amount of product that's being created. And then I make it colder. So that means it's colder. Now it wants to produce energy to try and heat it back up and avoid that change. So it's going to go to the right, which means I'm going to get less nitrogen. Oops. Less nitrogen, and then I'll come back to equilibrium. Less hydrogen. And more ammonia. The system will probably end up a little bit colder than it was to begin with, but not as cold as it would have been had the equilibrium not shifted. The equilibrium shifts to try and keep the change from being too great. So that's what LeChatelier's principle is, and it sort of works for all the different kinds of changes you can make. In subsequent videos, I'm going to go through why changing a concentration or changing a temperature would cause an equilibrium to react like this, instead of just using the principle explaining it based on what's actually happening with the particles in the system.